Hi everyone, in this video we're going to go through the remainder and factor theorems, but before I kind of jump straight into them, I want to do two things. So one is we're going to do this question just below so I can, it's going to help me explain what we're doing, but then to help me explain what we're doing in this question, I'm going to do a question from one of the other worksheets I've given you. So this worksheet here, all the questions had a remainder of 0, which meant then you could go on and factorize it. So I'm going to jump to this one here just because, I don't know, I feel like I did some in class, so I'm just going to make the assumption that you may not have done this one here. All right, so let's divide it in. So x into x cubed gives us x squared, then multiply that by x minus 1. So we get x cubed minus x squared, and then we're subtracting them. So x cubed minus x cubed gives you 0. 2x squared minus negative x squared is going to be plus 3x squared. All right, so don't forget your two negatives. And then we're going to divide that through again. So 3x squared divided by x gives us 3x. And then multiplying that through gives us 3x squared minus 3x. And don't forget we've got to bring that negative 13x down. All right, so we're going to just subtract those terms. All right, so 3x squared minus 3x squared gives us 0. Negative 13x minus negative, so plus 3x is going to be minus 10x. And then we start the process again. So negative 10x divided by x gives us negative 10. And then we're going to multiply it through. So negative 10x plus 10. Bring that 10 down, so plus 10. And don't forget we're going to be subtracting. And we should end up with 0 on this sheet. So I've created them all so you get a remainder of 0. So negative 10 plus 10 is 0. 10 minus 10 is 0. So we've got a remainder of 0. So when I'm doing my answer, all right, one of our factors is going to be what we divided it in our divisor, x minus 1. And then we're left with x squared plus 3x minus 10. Now we need to factorize this quadratic, so I'm going to just keep that as x minus 1. And remember, we need two numbers that multiply to give us our constant, which is negative 10. And the same two numbers we need to add to give us our coefficient of x, which is 3. So you're thinking of factor pairs of negative 10. So you can have 10 and 1, you can have 5 and 2, and I think that's it. So one of them does have to be negative. And if we have a look at the number 3, so that means we're going to do 5 minus 2. And then 5 times negative 2 gives us negative 10. 5 minus 2 gives us 3. So I'm going to have x plus 5, x minus 2. All right, so that's the factorized form. So this is our factorized form of this expanded form. So they're the same thing, they're the same graph, but remember the factorized form allows us to find our x-intercepts. All right, so moving on to the video today, getting on to our factor and the remainder theorems, and I just want to have a look at this question. All right, so this one here, it says there are 3 values of k, so 3 values of k, for which p of x equals x cubed minus 2x squared minus x plus 2 divided by x minus k gives a remainder of 0. We have to find the 3 values of k. Now, if we look at the previous question that we just did, the values of k for this one would be 1, all right, negative 5, and 2. And the reason for that, if I just go back, oh, and it's auto-saving. I hate it when it auto-saves. Because we've got a minus there, k is just whatever that number is. So if it was x plus, then that's why I wrote a negative in front of it. All right, so what we're going to do is just try different values of k. All right, so let's try k equals 1. If it's going to write for me, you're going to write for me. Thank you. All right, so let's try k equals 1. So we're going to do x minus 1 into x cubed minus 2x squared minus x plus 2. All right, so we're going to divide that in. So it's going to be x squared. I probably should pause the video when I do this, shouldn't I? Hopefully I don't make a mistake while I'm talking, so I might just quickly check that. That looks good. So 0, negative 2x squared minus negative 1x squared, so plus, so it's going to be minus x squared. And then we're going to have negative x squared. And then negative x times 1 is plus x. Bring that negative x down. All right, so we're going to have negative x squared plus x is 0. Negative x minus x is minus 2x. And then we're going to divide it through again, so negative 2. Negative 2 times x is negative 2x. And negative 2 times 1 is 2. Bring that 2 down, so plus 2. And we're going to do our subtraction. And you know what? I can see it's already going to be 0. So negative 2x plus 2x is 0. 2 minus 2 is also 0. So that means I know one of the solutions is k equals 1. All right, but this is where your remainder theorem comes into it, and your factor theorem, because we need 3 values of k. And to be honest, I hadn't done this question before, so I just chose k equals 1, but won't always work. So I could try k equals 2, k equals 3. You know, I could be trying it forever. And, you know, as you move into methods, all you need is just one solution, okay? But it might take you a couple of goes to get it. So if I didn't get a remainder of 0, I would then have to try a different value of k. But because I got 0, that's great. I can stop because my answer, my factorized form, not the answer to the question, but my factorized form is x minus 1. And then we've got x squared minus x minus 2. So I just need to factorize that quadratic like I did before. So 2 numbers that multiply to give me negative 2 and add to give me negative 1. So that's going to be x minus 2 and x plus 1. All right, so negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So that means my values of k, so it's 1, it's going to be 2, but the x plus 1, we need a negative in the middle, okay, and this is a positive, so we can just read that as x minus negative 1. So our value of k is negative 1. So final answers are going to be k equals 1, 2, and negative 1. So that means each time I put in, so 1, 2, or negative 1, in here, I'm going to get a remainder of 0. It's going to allow me to factorize it. Okay, so that's how you do it by hand. There is an easier way to do it on your calculator. So I'm going to show you that. All right, so I just had to make the screen a bit bigger. I don't know what happens on my video when I do that. Okay, so this is where define comes in helpful. Now, it's p of x here. You can call it f of x. If you feel like you're going to get confused, with your letters, just go to A, B, C, and then find P, and you can use P there, but I'm not going to use P, so I'm going to just use f of x. Equals x cubed minus 2x squared minus x plus 2. All right, so all I'm doing is telling the calculator, all right, calculator, please remember this function. So we've got x cubed minus 2x squared minus x plus 2. So you just want to make sure you've entered it incorrectly. All right, so first of all, our remainder theorem. So basically, it's going to tell you what your remainder is. All right, so we're taking this value of k. All right, so see how it's here, the same value. Remember what I said before, if it was a positive, we're just going to put 2 negatives. So your value of k is negative 2. So you see that. So on your calculator, you can just say, all right, hey calculator, can you just tell me what happens when x is equal to 1. All right, so we're just putting that in. It's going to be 0. All right, that's basically what we just did here. Okay, same thing. The other values of k we had, what were they? 2 and 2, I think was the other one, wasn't it? 0 and -1. They're all 0. If I did something else, so let's say I tried 3, it's not going to be 0. I already know the 3 values that equal 0, so your remainder is 8. You can do, -2. You're going to get a different value. So what we effectively want is just values of k that gives us 0. All right, that's what the factor theorem is. Okay, so instead of doing this and doing trial and error to figure out what your factors are, on your calculator, you can just define the function and then just try out different values for k. So k is basically just substituting in for x. All right, so let's have a look at doing some questions. All right, so question 4, it says, decide which of the following are factors of p of x. So that just means we're just going to look at what the value of k is. Oh, I shouldn't say k, but what we're going to put in. So I'll just write this one, we're going to substitute in p of 1. This one is going to be p of -1. This one is going to be p of 2, p of -2, p of 3, p of -3, p of 4, and this one's going to be p of -4. So we don't have to do, 8 lots of long division to get our remainder. All right, so going back on the calculator, you can just use F, you don't have to use P. All right, so defining it again. Sorry, I didn't go to define. So define. You don't have to clear anything because the calculator has a terrible memory. So once you define a new f of x, it just forgets all about any other f of x it's ever seen in its life. So x cubed minus 4x squared plus x plus 6. All right, always just check that it's written correctly because we're doing a lot with that function. All right, so for question A, all we need to do is say, oh, hey calculator, can you work out f of 1? It's 4. All right, so let's just write our answers down here. We get a remainder equals 4. So therefore, not a factor. So therefore, x minus 1 is not a factor. All right, now I'm not going to keep writing that. All right, so we'll just say what the remainder is and whether it's a factor or not, because that's going to take me forever. All right, but what won't take you forever is putting it into your calculator. So you can either write f of, -1 again, or you can actually just change the one you did further up and just press enter there. You don't have to have a new line. And it's 0, which is awesome. So your remainder, it's going to do that, remainder equals 0, therefore x plus 1 is a factor. All right, question C. All right, what are we doing? F of 2, also 0. So your remainder, whoops, okay, go back to pink then. Therefore, x minus 2 is a factor. All right, and let's just have a look at what other ones are factors. All right, because I don't really want to keep doing them. What was the next one? -2. All right, not 0, so let's do the next one. So question E, f of 3 is 0. So E has a remainder of 0, therefore x minus 3 is a factor. Now we do have our 3, so you're only going to have 3 factors, but let's just go ahead and show that the other 3 in the question are not going to work. So f of -3 for question F, f of 4 for question G, and what was our last one? -4, f of -4. Okay, so what you can do is you can find the factored version or factorized version of this polynomial. So your polynomial in expanded form is this, but in factorized form, it is x plus 1, x minus 2, and x minus 3. All right, so you don't have to go ahead and do that long division. Now, your calculator actually won't just do the division for you. This is the only way you can really do it on the calculator. And actually, the only way that I know of, I don't want to say with 100% certainty, but I have explored and tried to do it. But this is, how you would do it on the calculator. So that is what your remainder theorem and your factor theorem basically are. So what we effectively want, so we kind of covered the remainder theorem. Let's just look at the factor theorem. So here they've called it the letter A, truck reversing outside. I called it K. Doesn't really matter. It's some number, and you want your remainder to be 0, then x minus A is a factor. Okay, so you can go ahead and do it on your calculator, but remember you're also expected to do it by hand. So make sure you also know how to do it by hand. All right, so let's scroll down to question 7. All right, so use the factor theorem to find all 3 linear factors of these polynomials. All right, so I'm going to do one by hand because you do need to know how to do it by hand. And we did do one by hand before. Okay, so that's kind of like the second one. Okay, so we're doing question A. So your cubic just goes in here. So we've got x cubed minus 2x squared minus x plus 2. And I'm going to try, let's do x minus 1. It's probably the easiest one to do. If it doesn't work, then I would just try something else, maybe x plus 1. All right, so x cubed divided by x gives me x squared, and then we multiply that through. Then x squared times negative 1 is negative x squared. So we're subtracting them. So that gives us 0, negative 2x squared plus x squared. I feel like we did this question before, did we? God, they're always going to look the same. All right, so negative x squared divided by x is negative x, multiplying through again, and then we've got plus x. All right, and then oops, didn't do that in pink. That's all good. Oh, I like to be consistent. Go away. I'll do you in pink. All right. Yeah, this is looking the same as the one we did earlier. So maybe I'll do a different one. Oh, it's negative 2x. It is the same, isn't it? It's looking the same. All right, so then we've got negative 2, negative 2x plus 2. All right, so that is going to give me 0. So we've got x minus 1, x squared minus, I can't believe it's exactly the same question. All right, it's all good. So what is that? What was it? X minus 2, x plus 1. All right, let's do a different one. Okay, let me have a look at them because I know, yeah, D doesn't look like one that we've done before. So let's do D by hand and then we'll do it on the calculator. And that was just a fluke that x minus 1 was a factor. I had not done that. Well, I had done that question before, but I didn't realize until we got into it that I had done it before. All right, so x cubed. Actually, I need a bit more space. Excuse me. All right, put my division sign there. And let's do x minus 1. X cubed minus 2x squared minus 19x plus 20. Now, always make sure that your division sign, symbol, goes all the way over. Okay. All right, x cubed divided by x is x squared. X squared times x is x cubed. And then x squared times negative 1 is negative x squared. Oh, the truck outside is being very loud. All right, that's 0 minus 2x squared plus x squared is minus x squared. Now divide that through again. Negative x times x is negative x squared. Negative x times negative 1 is plus x. So bring down that 19x. And then we're going to subtract. Okay, so it's going to be 0, negative 19 minus 1x is negative 20x. And then we're going to start the whole process again. So minus 20 up there, negative 20x plus 20. Good, this looks like it's going to be 0. Didn't really plan on it being a remainder of 0. It just means less working out for me, which is good. All right, so that we do get 0 at the end. So that means x minus 1 is a factor, and then we just need to factorize this quadratic as well. All right, so two numbers that multiply to give us negative 20 and add to give us negative 1. So that's going to be x minus 5 and x plus 4. So if I was doing this, this division, any of these factors, so x minus 5 into, your dividend, or x plus 4 into it, would give you a remainder of 0. Now, if I did say x plus 1, it wouldn't work. And I kind of feel like I owe it to you to show you one that doesn't work. So I might actually need to open up a blank document to show you. Okay, so let's do x plus 1, just so you don't think it's always going to be 0. And I need to remember what the question is. Not that one. X cubed minus 2x squared. X cubed minus 2x squared. From memory, it was 19x plus 20. Just bring that over a little bit. Just double check that, because I'd hate to do the question and have it wrong. All right, so let's do this one. So I know it's not going to have a remainder of 0, but let's assume that we didn't know that. All right, so x cubed divided by x is x squared. X cubed minus x squared. Sorry, that should be a plus. All right. X cubed minus x cubed is 0. Negative 2x squared minus x squared is minus 3x squared. All right, start the division again. Okay, and we're going to bring that 19x down. All right, so that's going to give us 0. Negative 19 plus 3 is negative 16x. So doing that division again. What's that going to be? Minus 16. Bring down that 20. And then we're going to do our last subtraction. Now I can already see that our remainder is not going to be 0, which is what I wanted. Because I wanted to give you an example of a case when it wouldn't be. So that's 20 plus 16. Is 36. The remainder, it doesn't really matter. It's either 0 or not 0. We want it to not be 0. So let's just check we're correct. Where's my calculator? All right. So all right, I'm not going to define it. So another way that you can substitute x in is to say given that, so your given that symbol is here, given that x is equal to negative 1. All right, so remember the positive becomes negative, negative. All right, and we get 36, a remainder of 36. So effectively all you're doing is substituting it into here to get your remainder. All right, so going through getting your remainder of 36. Now, where are we? Which question are we doing? Let's go back here. Okay, so we came through here, got 0, and we're able to keep going. You can just substitute in, and that's what your remainder theorem is, substitute it into your expression. So I'm just going to get rid of this here, because I want to keep it in the same spot. All right, so let's do it in a different color so you can see. So I did the remainder theorem on the calculator, but I probably should have done it by hand. So if you've got x minus 1, that means we've got a is equal to 1. So all we're going to do is substitute in f of 1. All right, so if we go back to the remainder theorem, it doesn't like scrolling. All right, so the remainder theorem, we're just substituting in what this is, which is what we did on the calculator before when we used define. All right, so going down. Oh, my writing's disappeared. Do it again. All right, so a is equal to 1. So f of 1, just substituting it in to your cubic. So 1 cubed minus 2 times 1 squared minus 19 times 1 plus 20. So all I've done is substituted for 1, x equals 1. Every time we see x, we put the number 1. That's what we did on the calculator when we did define. So 1 cubed is 1, 1 squared is 1, so we've got minus 2. 19 times 1 is 19, so minus 19 plus 20. All right, so that's going to give us 0. All right, so you don't have to go through and do your long division to get a remainder of 0. Using your remainder theorem, which is what we did here, or using define on your calculator to get 0 is another way you can do it without doing the long division. But I think the practice of long division is good. It's a skill you do need. We can't always just do everything on our calculator. All right, so quite a long video. Let's just recap the remainder theorem. All right, so the remainder theorem just means, let me delete what I've already highlighted. All right, so we're dividing a polynomial by x minus a, and your remainder is given by substituting a into your polynomial. Just notice that came up with us. All right, so that's the last thing we just did. All right, so going back down, that's what we did here in green. All right, we just substituted a value of a into it and got 0. If we didn't get 0, then it's not a factor. And we also did that on our calculator back up here when we defined the function. All right, we defined it and we just substituted in different values for a. I think at the time I called it k. Doesn't really matter. All right, then your factor theorem. When your polynomial is divided by x minus a, the remainder is 0, and the remainder is 0, sorry, then x minus a is a factor. Okay, so that's what we did when we did the long division, showed it was equal to 0, and then we're able to factorize it. So that's why you want it equal to 0. All right, if you get a remainder that is not 0, then you can't put that polynomial in its factors. So with this example here, you've got your polynomial x cubed minus 3x squared minus 3x plus 10. We've shown that x minus 2 is a factor. And another factor is also your quotient. All right, so they're same thing. But then we go on and factorize this quotient. Now, if you can't factorize it, If you can't factorize it by doing two numbers that multiply to give you 5 and add to give you -1, like this one here, you need to factorize using the quadratic formula, but we're not going to do that at year 10. Okay, so you'll be given ones that you can easily do. All right, otherwise, in year 11 and 12, you'd go in and use the quadratic formula, but we're not going to do that. All right, very tricky stuff. The best thing you can do is get familiar with the calculator and learn how to do long division. All right, guys, bye.